My name is Wang Chenguang from Beijing Electronic Science and Technology Institute. Today, the title of the paper I want to report today is Efficient Equality Test Technique Using Identity-Based Encryption for Telemedicine Systems. I will introduce my paper in 4 parts, namely introduction and contribution, background and building blocks, detailed construction, and conclusions. First, I will introduce the background and contribution points of my paper. Identity encryption was first proposed by Huiyan in 1984. It mainly shows that the communicating parties can safely encrypt and decrypt information with the help of the public key ensured by a third party. So what is the equality test? Equality test refers to the equality of underlying messages of two cyber tests encrypted with different public keys can be tested without decryption. Equality test techniques also have a wide range of applications. For example, preserve privacy, data statistics on cloud database, and matching technique. The system model for the application of equality test technology in this paper is shown in the figure. The designed system model supports revocable functionality and is oriented to the field of telemedicine systems. There are 3 main entities in this model: them users, key generation center, and cloud server providers. Users are divided into 2 types, namely senders and receivers. In a telemedicine system, the sender is generally a patient and the receiver is a doctor. The sender passes the plain text to the cloud server. The receiver decrypts the cyber text from the cloud server, and both the sender and the receiver send test trapdoors to the cloud server. And the cloud server provider receives the cyber text from the sender and passes the cyber text to the receiver. And the cloud server receives the cyber text from the sender and it passes the sorry, my eyes is a little hurt. Oh, it's okay. And the cloud server provider receives the cyber text from the sender and passes the cyber text to the receiver.
Mr. Chen,
yeah.
Excuse me. The slides are not moving.
Slides? Yeah.
Point slides are not moving. Can you check it, please?
Yeah. And the cloud servers and the cloud server receives the cyber text from the sender and passes the cyber text to the receiver. And the cloud server processes the equivalent text trapdoors from both the sender and the receiver and outputs the test results. The main function of the key generation center. The main
Excuse
function
me,
of
Mr. Chen. Yeah. Excuse me, I'm sorry to bother you. The PowerPoint slides are not moving. It shows the first slide. Yeah. Can you move?
The main function of the key generation center is to generate keys for the sender and the receivers. Send the public key to the sender and send the private
Thank you.
private key.
你好，哥们儿，不好意思打扰一下，喂，不好意思打扰一下，你那个你这个幻灯片没在动啊？是不是那个分享错那个 monitor 了？那个你这幻灯片
现在放第6张，老师你看不见吧？老师？
哦，对，就没看见，没在动啊。现在动了，行啊，
不好意思
啊，没事，OK， 好，谢谢你。
我在讲我这个模型的这个原理，对，
OK， 好，谢谢，OK， 行。
The main function of the key generation, the main function of the key generation center is to generate keys for the sender and the receiver, send the public key to the sender, and send the private key and update key to the receiver. Next, I will introduce the contribution points of this paper. This paper proposes for the first time an equivalence test scheme with revocable identity-based encryption based on lattice cryptography. The encryption algorithm in our scheme uses a programmable hash function to compress the key length. The scheme in this paper is based on the difficulty of the LWE problem, which proves that the selected cyber test is safe under the random fiber model and can resist post-quantum attacks. Finally, the scheme is applied in the telemedicine systems. Judging from the parameter analysis results, our paper analyzes the efficiency of the solution from two representatives. You can see the solution is more efficient than other solutions in terms of storage performance and computing performance. The background knowledge involved in the paper is lattice. The definition of lattice is the range of the entire grid is represented by the linear combination of a set lattice spaces. The advantage of lattice is post-quantum secure and easy to implement. There are many line steps in the specific plane construction in this paper. In the setup phase, public payments and master private keys are generated, and in the pre-key generation and key update stages, the identity private key and update key are generated representatively. The dict key generation algorithm is used to generate decryption keys. Then the encrypt and decrypt algorithm implement encryption and decryption of plain text representatively. TD algorithm generates trapdoor for equality test. Test algorithm is used to output result of equality test. The V algorithm implements the update and the revocable list. Finally, I will present the conclusion of the paper. This paper proposes for the first time an equality test scheme with revocable identity-based encryption based on lattice cryptography. And this scheme is designed to use the hash value without embedding payment in the encryption algorithm as input, and it introduces a program for hash function, and the hash value of the planet is embedded as input in an equality test algorithm. Then it was verified that the proposed scheme is efficient in terms of storage overhead and computing overhead, and it was proved that the selected cyber test is safe under the random occur model. Thank you for your listening. Thank you.